Okay, in this video, I'm gonna solve the online homework problem, um, the chapter 3.4 and 3.5, the online homework set, problem number 3. So the question is this: when the velocity v of an object is very large, the magnitude of the force due to air resistance is proportional to v squared, with the force acting in opposition to the motion of the object. It means that the force due to the air resistance is proportional to v squared. So we're gonna get the instead of a negative b times v, we're gonna get negative b times v squared. So here b is the constant of the air resistance, and then the problem says that the mass of the object is 5 kilogram, and then the shot upward from the ground. So there is an object initially on the ground, and then going the upward. And then we set the upward as positive direction, and then the downward is a negative direction. Okay, so, and then the problem says the initial velocity is 5 meter per second squared. So v over 0 equals 500 meter per second. And then since the object initially was on the ground, so x of 0 equals 0. So now then the differential equation is this, okay, m times dv dt, that from the this is ma in Newton's second law of motion. This is equal to F1 plus F2. Okay, so F equals ma. So net force is going to be negative mg minus b times v squared. The reason that I put the sign of F and F2 is negative, because when we set the downward, there's a negative direction. Because gravitational force acting on the object, the direction is downward. And the force due to air resistance, the direction also is downward. So there's negative. And then if the problem says that if the magnitude of the force due to air resistance is 0.1 times v squared, so it means that b is 0.1, and then they said gravity is a 9.81. So the question is this: the object reach its max. When will the object reach? I'm sorry. So here, the question is, when will the object reach its maximum height above the ground? And then what is the maximum height? So when the object reaches the maximum height, and then at the moment object gonna stop, it means that velocity is 0. So using that fact, we can find out the t when the object reached the maximum height. And then using that fact also we can find out the x of t position when where the object is in the reach the maximum height. So first, what we have to do is to solve that differential equation. Okay, so yeah, I know it looks like the linear equation or Bernoulli equation. So I thought it was a Bernoulli equation, but it's not, because of negative mg. And there's no v term, right? So this is we have to use this is the separable equation. So we have to use the method of separable. Okay, so I'm gonna move m to the right hand side. So we got this, and then a second. So right. So now then I'm going to move the right hand side to the left hand side, and then we move dt to the right hand side. So we're going to get this. Now then I want to use this one, that formula in the integral table of integral. Okay, so 1 over a squared plus x squared. The integral of this guy is equal to 1 over a times the arctangent of x over a. So to get the a squared plus x squared, this form in here, I'll factor the m over b in fraction, and then the mg becomes a square root of mg over b squared. Okay, I know that. Yeah, we'll get the, once we factor out the m over b in the fraction, we're gonna get the mg over b. But to match the form of the bottom one with this a squared plus x squared, we could express mg over b as square of square root of mg over b. Okay, and then the right hand side is obvious, negative 2 plus c1. Now I'm going to move the m over b, that fraction, to the right hand side. Then we get this, and then now, so I'm not going to isolate. I'm not going to isolate v. Okay, it means I'm not going to solve v because it's going to get more complicated. So the goal is to find out what the time when the velocity, the object reached the highest, the maximum height, which means that we want to find out time when the object reached the highest, the maximum height. It means that velocity equals 0. So to figure out that, first we need to figure out C1. See that unknown constant of integration? I mean, right here, I'm sorry, C2. Okay, so now then I'm going to use this one, V of 0 equals 500, which is the initial condition, kind of. So then we're going to plug in 0 into D and then plug in 500 into V. So we got this. But you know what? This one, I mean, the I'm sorry, then the t term, the right hand side, is going to be 0. So we got this, and then plug in m, g, and b, all and the values of parameter into here. Then you can I'll get this. Okay, so but for when you solve your own the online homework problems, then you plug in your own the m, b, and g, the parameters, into that formula. You get the your own the C2. And then now the so we figured out the C2. Okay, so here we figured out C2, which is this. And then the what at v, what we need to solve this equation. Okay, that equations for t at v equals 0. Why? Because we want to figure out time when the the object reached the maximum height, which means that the velocity equals 0. Because when the maximum reached the maximum height, velocity gonna be, should be 0, right? So we plug in 0 into v. Okay, then everything is known except for t. So this is equation for t. So we solve that equation for t, then we're gonna get the this c2 equals b times t over m. Here, since v equals 0, the arctangent of 0 gonna be what? 0. Okay, so because the graph of arctangent is this. Okay, so here is the pi over 2. That's the negative pi over 2. Okay, so arctangent is defined on I mean, the range of the arctangent is negative pi over 2 and the pi over 2. And then arctangent 0 is what? 0. Okay, so the left hand side gonna become 0. Okay, so we can then we solve that. So we get this, and then we solve the equation for t. Then we're gonna get this. Okay, so m is in my problem, m equals 3, and then b is 0.1, and the c, we already got c in here. Okay, so now then t is gonna be approximately 2.69. So we got answer for the first question, when the object reached the maximum height, which is 2.69 seconds. Now, second problem, to figure out the maximum, what is the maximum height? I thought we have to take integral of the v of t. I mean, to do that, we have to solve that equation for t, v. I mean, we have to isolate v and then take an integral of v. That's more complicated. So I'm not going to use that way. Okay. So instead of that, I'm going to use some kind of tricky. It's a chain rule. I'm going to use chain rule. So dv dt can be expressed as a dv dx times a dx dt. Okay. So I know it dv dx, maybe it doesn't it doesn't make sense, but mathematically we can say that. Okay, so dv dt, we plug in, we're gonna express, involving third variable, which is x and dx, we could express dv dt as like this: dv dx times dx dt. So now dx dt is what? Dx dt is a derivative of potential function, which is a velocity. So dv dx plug in, replacing dx dt by v, we're gonna get dv dx times v. So dv dt can be expressed as dv dx times v. So now plug in dv dx times v into the dv dt in the original differential equation. Then we're gonna get this: m times, so m times v times dv dx is equal to negative mg plus v b times v squared. So now this is a separable, so we're gonna apply the method of the separable equation. Okay, so this is similar to what we did in step 1. Okay, so first they separate the v and x, then we're gonna get this here. I'm not gonna express mg over b as a square of square root of mg over b, because see that here numerator in the top is a v. So this can be evaluated by using the u substitution. Okay, so now applying u substitution, or you're gonna get the 1/2 times the natural log absolute value mg over b plus b squared is equal to negative b over mx plus c3. Now, see, look at this, mg over b, this is a positive, right? Because mg, b, all three parameters are positive, so the fraction must be positive, and the v squared must be positive. I know just the velocity must be decreasing until the object reaches the maximum height. But anyway, this is positive, right? Why? Because we set that upward direction is a positive direction. So object moved to upward until here. So velocity positive. So mg over b plus v squared is positive. So we don't need to put absolute value. So take it out. So we got 1/2 times natural log mg over b plus v squared. So now then, what's the goal? Here, the goal is to find out the maximum height when v equals 0, right? So that's the goal. So eventually, we're going to plug in 0 into v, then we can figure out x, which is the answer, right? But C3, we need to figure out the C3, which is the unknown constant integration, right? Now then, using this, x of 0 equals 0, and the v of 0 equals 500. Keep in mind this, when t equals 0, initial velocity 500, also initial position must be 0. So using those two conditions, we can figure out C3. So I'm going to plug in 500 into v, and I'm going to plug in 0 into x, okay? Then we're going to get this, right? See, 1/2 times the natural log mg over b plus 500 squared. So yeah, using calculator, you can figure out the decimal expression of this, okay? So now what you're gonna do, once we figure out C3, then I'm gonna plug in 0 into V, okay? Then solve the equation for X, then we're gonna get this, okay? You see that C3, we got C3 right there, okay? And then we'll plug in 0 into V, okay? And the X is the only variable which is unknown, right? So solve the equation for X, we're gonna get this. Which is this, okay? So the I didn't plug in a specific value into MGB because why? Because I want to use so that you can plug in your own parameters into that formula. Okay, so there is other way. Example 5 in a 3.4. Let me see. Also give you the give me a second. In the example 5, in chapter 3.4 give you the formula of the velocity. Okay, so the maybe you have tried to use this one, but the it's maybe it works for maybe it works when you find out the time when the object reached the maximum height, but you cannot use this one to find the answer for the second question, what's the maximum height, because the x position function x is not involved here. Okay, so that's a big problem. So now then, I think this is the best way to find out the answer for the question. Okay, so I'll stop here. And then if you have any questions, just let me know.